Okay, let's begin. Exercise 1C. So we're moving back to chapter 1, simultaneous linear equations, solving linear equations. We're going to start off pretty easy, but then I want to get a bit in depth about simultaneous equations. I know you've done it in year 9 and you've done it in year 10 and you might be proficient, but I don't think there's a lot of understanding behind it. So I'm going to make sure you understand it. So we're going to spend a bit of time on theory. You can listen to this again on YouTube. Hopefully you understand it. Make sure to understand it. It's important for next year because you're going to do quite a bit of simultaneous equations. You've got to know why you're doing it and what it's actually solving for. Then it makes more sense. Okay? Here we go. This is a simple type of equation. You can copy it down or you can check the PowerPoint later, but the solutions are coming up. And this is a 2 minus 2x on 5 equals to 2x plus 7. And naturally, you would try to balance the equation. Okay, you want to balance the equation, so you know what I said last lesson, you could do whatever you want. You could do like plus 3, add 3 on both sides if you want. It doesn't really matter. Okay, so you can say inverse of positive 7 minus 7 on both sides, and you cancel out the 7, you get 2x equals to 2 minus 7 is negative 5 minus 2x on 5. That's okay too, nothing wrong, yeah? Now, your aim is to solve for x, and most likely solving for a linear equation, what you would have done is the most easiest way is to multiply both sides by 5. Now this is where some students will make algebraic mistakes. You got to remember, if what you learned back in year 7, what they said is, whatever you do to one side, you do to the other side. True? So your aim is just to keep the scale balanced. There is no difference here. If this is divide 5, the inverse of divide is times. But you can't just say, let's just times that term individually by 5, and then times that by 5. Okay? What you got to understand is this entire term is the left-hand side. So when you times it by 5, you got to remember it's 5 times 2 and 5 times 2x and 5. And same thing with this one. This is your right-hand side. So if you times that by 5, that is also 5 times 2x times 7. Why you do that is because 5 times 2x on 5, naturally 5 divided by 5 is 1. That's why it cancels out nicely. 5 times 2 gives you 10. That gives you your 2x. And then 5 times the 2 over here gives you 10x. And 5 times 7 gives you 35. And then from there, back to year 7 mathematics, pretty straightforward. Okay, move all the x's to one side, add 2x on both sides, minus 35 on both sides, and you can solve for x. Okay, so these are the steps that you would have taken. You would have added 2x on both sides, so that becomes 12x. You would have minus 35 on both sides, because that's positive 35, and 10 minus 35 is negative 25. And then you would have got your answer as x equals negative 25 on 12, and you're like, yes, done. My next question is, what is that for? Why'd you do that? What's the purpose of doing this? Like, what does this mean when you say x equals 25 on 12, which is roughly about negative 2.0888 or 8333? What does that tell me? See, besides knowing the mathematical part on how to do it, you spent 7, 8, and 9, and 10 to solve this. What are you doing? So you just figured out x, but what is x representing? What is that finding? Anyone know? What is x finding? Yes, Jamie.
Is it the x value to make this equation equal to only 1?
It is the x value to make this equation equal to the other equation, which is exactly what the theory is about here. When you say this equation equals to the other equation, what equation do I have right now? Just look at the equations. What is it? 2 minus 2x and 5. What kind of equation is that? Yeah, it's linear. Because x is to the power of 1. If the fraction confuses you, look at the right one. The right-hand side, 2x plus 7. See, 2x plus 7 right here, that's a linear equation. This is a linear equation because the value of the power of x is x to the power of 1. Technically, another way of writing this is y equals to negative 2 on 5x plus 2. That's the same thing. I'm just rewriting it. So right now I've got a gradient of negative 2 on 5 and y-intercept of 2 for that blue equation there. Okay, so this is your gradient. So you remember mx plus c. Yeah, that's your straight line equation. So what Jamie just said was 2 equations equal to each other and you just found x, the solution to that. So my question is, all right, so now we know what the equation is. We've got 2 straight lines. What does it mean when you say 2 straight lines equal to each other? Why'd you do that? What does that mean? Jamie again.
When they intersect, the two points intersect.
Where it intersects. And this is one of the things where I don't think a lot of students understand. When you equate something, why did you equate it? Like, why would you just equate it because you can? No. You equate it because there's a reasoning to this. You got a straight line, so negative 2 and 5x plus 2, it's a negative gradient, and it's y-intercept of 2, so let's just say it looks like this, hypothetically. Okay? And then you got your second graph, which is 2x plus 7, so let's say it looks like that, with y-intercept of 7, because that's your c. Okay? Why is it that equating it tells you the intersection? Because the point of intersection right now, that's an x and a y coordinate. True? Since they both have an x and a y coordinate, what I want you to realize is that means for the blue line at this coordinate, that y value, let's say it's negative 2, 1. I'm making it up, okay? It's not the right answer, but let's just say it was negative 2, 1. That means negative 2, 1 is a coordinate on the blue line, but it's also on the red line. So what does that mean? That just means that for the red equation, y equals to 2x plus 7, what you're saying is these two y coordinates, if this was 1, the x values should be negative 2. That's why you can say, oh, that means these two y values are just the same. If they're just the same, well, why don't I just write 2x plus 7 here? That's why you equate it. See, every time you equate it, what you're really just saying is just saying the y coordinates are the same. You're just using substitution. You're just saying sub y into this equation because the two y coordinates are the same. So you sub it in, you're saying, all right, well, that y coordinate, if it's 1, that's also 1. So you're just saying 2x plus 7 equals to negative 2 on 5x plus 2. That's why it's the point of intersection. That's the reasoning behind it. Okay? So now that you know it's the y coordinate, you've just said the y coordinate's the same and you solve for x. So what is this x? So what is this? Now that we're sort of understanding the picture, what is the x telling me? X at negative 2.0833. What is that telling me? What is that telling me? So I equated it because I said these two y's are the same and I solved for x. What's x telling me? Yes, Ricky.
How to say the meeting point of the two lines.
Yeah. Yeah. It's the x coordinate because you see, I said the intersection point has an x and a y coordinate. What you did was you substituted y into this equation so that you can solve for x. That's what you've been doing. Since year 7, 8, 9, 10, that's what you've been doing. You've just been solving for x and y, and you learned simultaneous equations, you learned substitution method, you learned elimination method for what? For this. Because all you're trying to find is the point of intersection of linear equations. That's why elimination method only works for straight line equations. Okay, and I'll tell you why elimination method works later as well. But that's all you're really doing. So when you look at this, it's not just a bunch of equations that we made up. It's actually telling you something. It's telling you got two straight lines, and when you solve for x, this is telling you the x coordinate where they intersect. You don't know what the y is just yet. You found out x. So how do you think I'm going to find out y? How are you going to find out y? You?
By using x. Oh, you go.
Yeah, you both go.
By using x, the x coordinates.
Yeah, because this is an equation. Remember, that's 2x plus 7 will give you the y coordinate. Now you know that x is negative 2.0833. If you put it back in here, times by 2, add 7, that should tell you what the y coordinate is, because that's what this equation is saying. They're saying, if you want to know what y is, tell me what x is. You just found what x is. You said, oh, well, x is negative 2.0833. Therefore, you can times it by negative 2 divided by 5 plus 2. Tells you y. But since it's the point of intersection, these two y's should be the same. And that's how you find the coordinate of intersection. And that's what you've been doing since year 7, 8, 9, 10. Okay, so 7, 8, 9, 10, 7, 8, you were learning how to inverse operation. By 9, you learned simultaneous equation, linear equations, what straight lines are. And then by 10, you had to be proficient at simultaneous equations. And then year 11, you're just now showing me what you know. But every time my year 11s come in, they don't understand what that equation really means. Like this, a lot of kids can do. But if I ask them, like, what are you doing? They're like, I don't know. And that's why I want to give you an application question. Why you find it hard is because you have no idea what you're doing. You're sitting there, you're like, I don't understand this. It's not that you don't understand it. It's because you don't know what you have to do. It's like me giving you a hammer and you got a, I don't know, you got a screwdriver. You got a screw. And you're like, what do I do with this hammer? Like, you don't need a hammer. You need a screwdriver. You know, it's sort of like I'm giving you all the tools, but you got to know why you're using these tools. And that's why I'm showing you this. Okay? Now, so we're moving on. We're like, okay, so this now tells you what does it mean, what I have, and it just basically means, and this is just me trying to show you, oops, just the visual aspect of me using the calculator. And you can now see this tells you the x coordinate, and if you sub it back in, you get your y coordinate. All right? That's what it looks like. Now, to solve this, this is just one of the exercises in your textbook that I thought was important because in this state, out of all the states, Victoria is the best in algebra, but as a nation, compared to the world, we suck at fractions. It's one of the things we just suck at. And it's just something about me putting over 5, over 3, over 2, over 3, kids can't do. But if I took it all away, x minus 2 equals x, everyone can do. If I took out that 2, x minus 3 minus 2x minus 4 equals 5, everyone can do. But if I put those fractions in, everyone can't. Okay? So what I want you to get used to is if you get a fraction, don't get scared. And one of the techniques that I want to teach you is the same thing. Same basic principle, balance the equation. This is my left-hand side. Okay, this is my left-hand side. This is my right-hand side. So balance the equation means whatever you do to one side, you do to the other. So if I don't like that fraction, well, I don't like fractions either, okay? It sort of delays my calculations. Get rid of them. This is divide 5. Now what's the inverse of divide 5? Times 5. So I can do that. I can say, all right, let's times this by 5 and times that by 5. Nothing wrong. You're still balancing the equation. So you hypothetically, technically would have cancelled out the 5. But then there's still that 3. Now that's divide 3. How do you remove the divide 3? You would times it by 3. So I can do that too. I can say, all right, let's times it by 3, times it by 3. Whoops. Okay, nothing wrong. I've still kept the balance. It's sort of like adding 1, adding 2, doesn't matter. I can do that. So if this is keeping it balanced, instead of times it by 5 and then times it by 3, why don't I just times it by 15? Okay, so what I'm really going to do here is I'm going to say, let's just times 15 to x on 5 minus 2 equals to x on 3 times 15. Now the nice thing about this, by doing this, you can, well, let me find the blue, okay? Now we can simplify. This is just fractions. This is just like saying x on 3 times 15 on 1. That's really what you're doing. Because 15 as a whole number can write as fraction as 15 over 1. Same thing with this one. This is just 15 over 1 multiplied to x on 5. So remember, you multiply to this term, and you also multiply 15 to the negative 2. So it will be minus 2 times 15 on 1. Okay, if the over 1 makes it confusing, I'll just remove that for you. Okay, but I want you to keep in mind that when you're multiplying, you can simplify. How do you simplify? Well, I look at these two numbers, I'm like, oh, actually, there's a common factor. What's a common factor? Highest common factor of 3 and 15? 3. Good. So how many 3 goes in 3? Once. How many 3 goes into 15? 5. So this changes it to 5x over 1, which is 5x. And over here, how many 5s go to 15 and 5? Well, I know that it goes into once, and I know that it goes into 3 times. That's what you're really doing. So therefore, this now becomes 3x minus, and 2 times 15, 30. Now if I asked you to solve this, how easy is that? Okay, so if you don't like fractions, nothing wrong. It still goes back to the very basic simple, principle, what you learnt in year 7, balance the equation. That's all you ever learnt in year 7. Balance the equation for algebra. Okay? And I'm not going to do any different for that one either. You can do the same. This is your left-hand side. That's your right-hand side. See, I've got 2 terms here. I've got 1 term, 2 terms. So when you times it by 2, remember you're multiplying to this entire thing, and you're multiplying to this entire thing. Okay? So that's just me trying to help you if you're struggling with fractions. I'm sure you can look at the example, and they'll give you the solutions. Like, I've just copied the solutions here. But what I wanted you to see was why they're times 15. Because the why is important. Once you understand why, you don't need to memorize. You don't have to do a lot. Study smart, don't study hard. Yeah? Study and understand it. Once you understand, you don't have to do many. Okay? If you don't understand it, you have to do many. Because you want to see as many examples as you can. Yeah? So that's how they did it. They got exactly to the step I got to you for you. Just then you do exactly the same drills. Okay? So same with the next one. Why are they times by 6? Just because if you times it all by 2 and then you all times it all by 3, it makes it easier. It cancels out. So naturally 6 and 2, this becomes 3 and 1. 6 and 3, that's 1 and 2. And nicely, this now becomes 3x minus 3 because it's 3 times this entire bracket, so don't make that mistake. 3 times this entire bracket, and then 2 times this entire bracket, so you've got minus 2 times 2x minus 4 equals to 30, and that makes it easier. Okay, now notice the way I'm writing my solutions. Every time I write it, I'm very careful with the signs and the brackets. I put in the brackets to separate them. You see, there was a minus sign there, I kept the minus sign. That was a 2, I kept the 2. And there's a times, and because they don't have the brackets, I put in the brackets to make it easier. Because if I didn't write in the brackets, this is the common mistake that students do. See, what's wrong with that? Because if you look at that, like, if you knew what you were doing, yeah, sure, you'll be fine. But if you didn't know what you're doing, or if you got distracted, you'd only do 2 times 2x, and you forget to multiply the 4. And that does happen with my year 12s, just because they had poor layout. And I don't know if I told this class, but layout, all my top kids in the 45 raw plus, in the top 2%, never had poor layout. Good layout leads to good results. Okay, so how I would do it is I wouldn't use the times there, I would use brackets to remind myself. Okay, and then from there, just expand the brackets as you would have and simplify and solve. Okay, so if you're afraid of the fractions, get rid of them. It's okay, you can get rid of them early on. Okay, any questions on that? No? Good, because that's the first part of your exercise for 1C. Now I really just want to move on to, that's your exercise. Now I've selected some questions for you to practice now, just to get the feel of it, especially with the fractions down here. Okay, so these fractions here, you still apply the same thing for D. Want to get rid of 3 times 3. Okay, so for every term. So I want you to practice it for now. Practice that. I'm going to give you about 8 minutes. And then on the next slide, I want to talk about substitution elimination method, why elimination method works for solving the point of intersection. Okay, so do that for me. You got A, D, F, I, A, C, E, G. If you don't finish it in 8 minutes, it's okay. That'll be your homework. Okay, the point of this session is for you to understand. Don't do a lot. Understand. Study smart, don't study hard. I forgot to hand out the payment forms last time I gave you the access action sheets. These are the payment forms. If you're interested, hand it in by February 17th. And I still recommend informatics. For question F, there's multiple ways of doing it. I like to just divide it. So divide the 3 on both sides first. So divide -3 divided by -3, because that's a time symbol there. So -3 divided by -3 is 1. And that just works nicer for me. I think most students would expand their bracket and then solve. You can. I just do the best way that for me to let less mistakes. And I normally make mistakes when I do negative multiplications. That's why I divide it. Okay, so, but as long as you get the same answer, it doesn't matter. All right, time's up. Make sure to check your answers to, especially the ones with the fractions, whether you got it right or not. But I'm trying to also give you a sample layout on how I write my solutions. Normally with my year 8s, I tell them to do those little red indicators so I know they're thinking right. But by year 11, I'm going to assume that you've got that nailed down. So you don't have to write that. You can just go step to step. Okay? Because that's how the year 12s will do it. Right? All right, let's move on to the next section. So there was just the question 1 and 2 was just me trying to get you to be comfortable with fractions. If you're not, do all of them. Okay, remember the questions I set is to help you. Just because I said 3 doesn't mean you have to do 3. You can do 1, you can do 10, doesn't matter. The whole point is at the end of this session, after you walk out, you can do them. You know how to do them, you know how to do, why to do, that's all I'm asking for. Okay, so the questions I set is just that I think it's enough for you to understand. Okay? All right, here we go. Now, this is what you learnt in towards more maybe mid year 9 and then somewhere in year 10 as well. 2x minus y equals 4 and x plus 2y equals -3, and they say solve the equations. Okay, so hopefully now you have a better understanding of what you're actually doing. These are just 2 linear equations. Again, this is just saying you got, if you rearrange this equation, you add y, whoops, you add, whoops, if you add y, whoops, if you add y to both sides, you remove the y, and if you minus 4 on both sides, then you get a new equation where it's y equals to 2x minus 4, and that's a linear equation. Same thing with this one. If you rearrange this equation, this is x plus 2y equals -3. If you minus x on both sides, you get 2y equals to -3 minus x, and then you divide both sides by 2, you get negative x on 2 minus 3 on 2. And that's a linear equation again. Okay? So what I'm trying to get you to understand is when you're looking at these equations, picture it. Realize it's 2 linear equations, and when you're solving for it, what are you really doing again? What are you doing when you're solving for two linear equations? Solve for x and y, what are you doing? Yes. Find the point of intersection. Okay, you can do this graphically, or what we're going to do is we're doing algebraically. Okay, now, when we're doing it algebraically, is there a button to remove? Yeah, cool. Now, when we're doing it algebraically, there are two methods, and the first method is called substitution method. What's substitution? It's just saying, let's replace the letter. Okay, because right now we've got two letters and two equations. We want to know one of the letters. We want to know what it equals to. So the traditional method is you can rearrange one of them. I rearranged the second one just because x was by itself, and I could just minus 2y on both sides. Minus 2y here and minus 2y here. I get that. Okay, so what this is saying is x is equivalent to this quantity. So if x is equivalent to this quantity, what I can do, what I can do is I can substitute x back in here. That's why it's called substitution method. Because you're saying, oh, well, this is equivalent to this. So why don't I just write it all in one equation and say it's 2 multiplied to negative 3 minus 2y minus y equals 4. Now, why do you want to do that? Is because if you substitute this in here, what you naturally nicely have now is just one variable. Whereas before, you had an x and a y. It was hard to solve. You had an x and y, it was hard to solve. You had two different equations, you didn't know what to do. This was one of the methods where if you rearrange one of them, then you can say, oh, this is equivalent to this much. I can substitute it back in. So now I've got one equation to deal with and only one variable. This goes back to what you were doing just now. So you can solve this now. You can expand the brackets and then solve for y. So if you expand the brackets, 2 times negative 3 is negative 6. 2 times negative 2y gives you negative 4y. Minus y equals 4. Collect the like terms. So negative 5y. Add 6 on both sides. So 4 plus 6 is 10. Divide both sides by negative 5 and you get negative 2. So now you get y. What does that y tell me again? So after doing all this gibberish, what does this tell me? What's the y tell me? Good. It tells you the intersection. Remember, you're just trying to find the intersection. There's two straight lines. You found the point of intersection, and that's the y coordinate, or the y value. So logically, all you're really having right now is you've got these two straight lines. I don't know where it is. I just know the point of intersection. I just solved. Y is negative 2. What I don't know is x. So how do I find x? Right there. You already figured it out. You said x will equal to whatever y is. Well, you just figured out y. It's negative 2. So negative 2 times negative 2 is positive 4. Positive 4 minus 3 is 1. So I already know that's my point of intersection. 1, negative 2. That's for these two equations. And you can sketch that and find the intersection. It will prove that too. Okay? But what I want you to see is what you're really doing. Why the substitution method works. Okay? Now, you put it back in and you get x equals 1. And that's your point of intersection. Now, if we do the elimination method, it should also give you the same answer. One of the things I'd like to emphasize with the elimination method is this step here. Most students, for me, I've always liked elimination method. It's much more, it's faster. It's more efficient for me and it takes less space. It's only these two. Back in when I was in high school around your age, I was very strong with algebra, so I did substitution all the way. Even when I got to year 12 specials, my algebra could take up 2 pages and I had to be very careful with all my signs. But if I had known about elimination methods, not that I didn't learn it, I was just too lazy. So I was good at substitution and I didn't learn elimination and I just stuck with substitution all the way. Until end of year, I learned elimination. I'm like, oh, what have I been doing? Okay, so I like elimination. You can learn either one. You can use whichever you're more comfortable with. I recommend you to learn elimination method just because it's more efficient. Okay, so what's elimination method? Elimination method emphasizes that you're going to make one of these variables an equal quantity. Meaning this is 2x, but that's 1x, not equal quantity. That's 1y, that's 2 y's, not equal quantity. What you want is an equal quantity, then you can add or subtract. Okay, and I'm going to explain why you can add or subtract. But first off, what you're going to do next is you're going to say, all right, to make an equal quantity, how about I times the bottom equation by 2. Because if I times the bottom by 2, this x, I just need another 2 to make this equal quantity. So if I times this by 2, I get 2x. If I times this 2y by 2, I get 4y. If I times this by 2, I get negative 6. Why did I do that? Because now the x's are of equal quantity. Now, up until here, this still makes sense. It was okay because you're still balancing the equation. You haven't changed anything. See, this is just the same thing as this equation, just double. Okay, you've just made it longer. That's all you've done. You haven't actually changed anything. The balance of the equation is still there. It's like saying 3 equals 3, and if I times this by 2, I times this by 2, that's 6 equals 6. The statement hasn't changed. You're saying 3 equals 3, 6 equals 6. They're both the same. Okay, so it's okay to say that equals that as well, because you times this side by 2, and you times this side by 2. Okay, so all I did was times this by 2, and I said times this by 2. So I'm still balancing the equation, nothing wrong. 2 times x, 2 times 2y gets you these two. Okay? Now, this is where a lot of students don't understand why, and they just do it. They're really proficient at it, they're good at it, but this is the step, and this is why elimination works here. Up in this step, once you make the same quantities, your aim is to add or subtract, as long as you eliminate. That's why it's called elimination method. Your aim is to eliminate the 2x's. So 2x and another 2x, what do I do to remove them? You subtract them. If this was a negative 2x, then you add them. But in this case, 2x minus 2x will cancel out. So by saying that, I'm going to say, all right, well, let's minus these two. 2x minus 2x will cancel out to be 0. You got negative y minus 4y gives you negative 5y. So negative 1 take away 4 is negative 5. Then 4 take away a negative 6. Two negatives become a positive, so 4 plus 6 is 10. Yeah? So then you get negative 5y equals 10, and then y equals negative 2. Exactly the same as what we had before. But here's my question, right here. Why can we do that? Why can we add and subtract? Just because I told you so? Just because everyone told you so and that's how you do it to solve? No. Why can you do that? Anyone have a guess? Then I'll tell you the answer. Technically, you learnt it back in year 7. It's just that we don't realize that we were doing it. Hey, good. Guess I can teach you something. So, remember in year 7, I told you that if you had x plus 1 equals 10, I said you can do anything to the equation as long as you balance it. So that means I can minus 1, I can minus 1, and that's perfectly fine. I can times 2, I can times 2. Now, let's have a look at what we did here. Okay? In this equation, let's say 2x minus y equals 4. What did we do? We said on this right-hand side, what did we do? We said 4 minus a negative 6. So what I'm really saying here is I'm saying 4 minus a negative 6. That's what I'm doing. So whatever I do to the right-hand side, what do I do to the left-hand side? You do the same. So minus a negative 6. So I'm going to go minus a negative 6. True? But didn't I already say that, look at this equation right here. I'm going to rewrite it again so you can see. It says 2x plus 4y equals. Doesn't that say there that negative 6 is equal to that? So what you really can do is, instead of writing negative 6, why don't I just replace that, just like you did in substitution? Why don't I replace that and put it back here? See, this was originally what? It was minus 6. And so if you put it back in, then it suddenly now becomes minus, and I'm going to write here, 2x plus 4y. Which conveniently, if you put in the negatives, negative 1 times both, it becomes minus 2x and minus 4y, which is exactly what you're doing here. But you're just balancing the equation. What's the difference between the two? It's just one looks like algebra and one's a number. So the numbers you get, it's just that when it's an expression, you're like, oh, I don't know what you're doing. But we already told you the quantity. We said that expression is equivalent to negative 6. So all you're doing is minus negative 6 on both sides. Is technically what you're doing. Okay, so it goes all the way back to year 7, balancing the equation. That's why elimination method works. That's why you can add both sides, or you can minus both sides, or you can times both sides, or you can divide both sides. And you're going to find that in year 11 methods when you guys are doing it, when you get to logs and exponential, and you're going to use elimination method as well, you'll find that they're going to divide there. And the reason why you can divide is because you're balancing the equation. That's why it's okay to divide, times, add, or subtract. Because you're just balancing the equation. Does that all make sense now? Yeah? Great. So, once you do that, that's elimination method. You find out what y coordinate is. Obviously, you just sub y equals to -2 back into one of the equations. So you can sub it back in here, and you'll find out x. And that tells you what again? The x and y coordinates. What does it tell you? The what? Yeah, the point of intersection. Yeah, okay, the point of intersection is just the point of intersection of two straight lines. Easy? All right, so that's what we're really going to be doing for the next few sessions in chapter 1, but I really wanted you to have that clear understanding why you're doing it, because then it makes sense. Okay, otherwise you're just blindly doing maths. Okay, and that's why it's magical, but it's not meant to be. It's meant to be logical. All right, so a bit of questions, why does it work? Now you all know why it works, so balance the equation. And do we all know how to do this on a calculator? How to solve? Hands up if you do. Hands up if you don't. All right, I'm going to do it. If you have a calculator, take it out, and we're going to quickly do it on the computer. Otherwise, watch on the screen. I'm going to show you how to solve a calculator so you can check your solutions that you're working. Okay, it's one thing to be good at maths, but also you got to be proficient and efficient. So here we go. If you have one of these CAS calcs, all right, first thing, you want to solve. You're going to be on your menu screen. Make sure to click the one on the bottom here. Don't go to A, don't do the calculate. Click down here, add a calculator. So now I've got a calculator. From the calculator, what I want to solve, because remember I had two equations. There's two ways of doing this. I can type it, I can just type solve and do the bracket. For you, it's menu 3-1, or just press menu. What we're trying to do, algebra. We're solving algebra right now. What are we doing? Solve. So that's why it's menu number 3, number 1. So you can just press menu 3-1 and you get it. So menu 3-1, you're solving. What are you solving for? You're solving for two linear equations. So there's two ways of doing this, and I'll show you the first way. This first way you would have done solve, and under this, next to the book, see the catalog here, you got next to the book, these are common functions. So if you press that, that gives you a list of common functions you do. You normally do fractions, you have powers, modulus, later on in methods, square roots and whatnot. What you're looking for is this one. So the box there, that's what you're looking for. So you're writing two equations in there. So what do I want? I want two equations, and what my two equations were just now, what were they again? There was 2x minus y, so 2 times x minus y equals 4, and the other one was x plus 2y equals -3. Okay, x plus 2 times y equals -3. Yeah? Now here's the thing, just pay attention where my cursor is right now. See how it's blinking right next to the 3? The calculator is not as smart as you, okay? So you just told it what to solve, but doesn't know what you mean. So it's like, all right, solve for what? You're like, well, isn't it obvious? It's not obvious to the computer. So you got to tell it that you want it to solve for x and a y. So that's why you're going to move the cursor. You press on the button. You're going to move. So your button's over here. You're going to press that button to move it across. And the cursor's now bigger. Okay. Now you've got to tell it what to solve. So you're going to do comma. Where's the comma? Yeah, comma. You're like, all right, this is what I want you to solve. You want them to solve x, comma, y. Now they know. Because you don't always have to solve x and y. Sometimes you just want to solve a letter A or B or T. You got to tell it, okay? So you might know, but you got to tell it what to do. So once you've typed that, you can press enter, and it tells you it's 1 and -2, just like we did when we had it manually, okay? So that's the first method. Second method is you can go to menu, and again, you can do algebra, but you see down here it says 7, whoops, I just moved away for a bit. Whoops, 3, look at 7. 7 says solve system of equations. Later on in uni and towards end of year 12, or in year 12, they're called systems because linear makes up systems. Binary code and everything's all linear, okay? So that's why they call it systems, but technically it's linear equations, okay? So we're gonna go to 7, and what we want is solve system of equations. Okay, so we want linear, or you can even go to solve system of linear equations if you want, doesn't matter. Okay, so if you happen to go to either one, so let's say linear equations, you ask, how many equations do you have? I got 2. What variables do I have? I've got an x and a y. Okay, and you just enter it in and follow. Okay, and then it gives you that. And you just type in the equations. Same thing. All right. Practice 1C, and the next session is still about simultaneous, so you're not falling behind. You're just learning better. Okay. I'll see you next session, which is tomorrow. Tomorrow's session. Good work.
You're